Welcome back. In this video, we are going to see another example for recursive function, which is going to be Tower of Hanoi. So you can see the picture, and you might have seen this kind of examples in your real life, toys format or some other format. You might have seen this. Computer games also there with this. Okay. So as you could see on the screen, the A, B, and C, they are known as pegs. And if you look at the first peg, which is having a finite number of disks, many disks are kept it. Okay, so what is our job is, what is the objective is, you have to move all the disks from peg A to peg C using B as auxiliary one. Auxiliary in a sense, B as the intermediate one. I hope you understood this. And the rule is going to be, you can move one disk at a time. You are supposed to take only the topmost disk, and this should be taken, and you can move one disk at a time. And the second thing is, you are not supposed to place a larger disk on a smaller disk. These two are the two cases. I repeat, you can move one disk at a time. At the same time, you are not supposed to place a larger disk on a smaller disk, right? So as you could see on the screen, where you can see three pegs, and if you look at A, there are n disks. All six is placed in A. That is in from larger at bottommost and the smaller one at the topmost. Right? Yeah. So let us see how we can do it. So if you take n is equal to 3, let us see how we can do it. If n is equal to 3, look at the first one. First picture says in A we have three disks. So what we do is, what is in the topmost. So what we are going to move disk from peg A to C. Next, move the top disk from peg A to B. Next, you can move the top disk from C to B. Next, we can move from peg A to peg C. Next, move from peg B to peg A. Again, move from B to peg C, B to peg C, and the last one is move peg from A to C. Now, if you look at C, C has got three disks and everything is arranged. And if you look at A is empty and even B is empty. You are at initial stage, everything was on A, and the final stage, everything is on B. And what is our job? Our job is to see that all the pegs in A has moved to peg C by taking the help of auxiliary peg, which is B. So it's very simple. You can see the diagram. If you take n is equal to 3, first thing is you have to move from A to C, then from A to B, then C to B, then A to C, then B to A, then B to C, then A to C. So this is the case when you take n is equal to 3. If you take n is equal to 1, it's simple. What you have to do, if n is equal to 1, directly you can move what is on A to C, because I need not to use the intermediate disk. To take n is equal to 2, we have got only two disks. What I do is, from A I'll move to B. Now the largest disk is on A, so from A to I'll move to C. Remember, from A to I'll move to C. After this, the largest disk is on C now. Now what is on B? I'll move to C. Move from B to C. We are done with this. So what is your job? Your job is to write an algorithm for this. So we taken the procedure name as star with 4 parameter. N is nothing but number of disks, and we use three different parameters. BEG, that is nothing but the beginning peg. We have AUX is for auxiliary, and end is nothing but the last disk. To take the previous example, B A stands for or BEG stands for A, AUX stands for B, and N stands for C. Okay, so let us see how we can convert this into a recursive function. So every time whenever we write a recursive function, we should have a base case and a general case. So what will be the base case for this when n is equal to 1? So look at the statement, look at the procedure. We give it as tar 1 comma beg aux end. If there is a single disk, I can move from beg. I repeat, beg stands for A, and I'll move from beg to the end. N stands for C. From A to C, I can move it directly, right? If n is greater than 1, if there are more than one disk. So what I have to do is we use a very simple technique. So we use the same function tower. What I do is I'm going to move n minus 1 disk from A. We call it as BEG. We'll move to AUX. AUX is nothing but auxiliary one, or we call it as B. So move n minus 1 from A or BEG to auxiliary by taking the help of END. END stands for C. When you move this many disks from the first disk to the second one by taking the help of the third one, what happened? The largest disk is going to remain in A or BEG. Now we can take it out directly, right? But how this n minus 1 disk is moved from the first disk to the auxiliary one, we are not worried. That you have to find the solution for that. So now what is there in A? A is having a single disk. So move that disk from A to the end. If you want, you can take the help of the auxiliary one. So we wrote it as BG. There is an arrow mark to end. Without taking help of AUX, we can do it. Now, where is the remaining disk? Only the largest disk is there in C. Rest all disk is there in the auxiliary one. So what we should do? We should take this n minus 1 disk from AUX. AUX stands for B or the middle peg. So from middle peg, you have to take all the disk and move to the last one, which is the end, or we can take it as C by taking help of BEG. BEG stands for A. From B to C, you have to move n minus 1 disk by taking help of A. We are done with the algorithm. So I hope you understood this. If n is equal to 1, we can move directly. If n is greater than 1, you have to move n minus 1 disk from A to B. Then take the last disk from A and move to C. Once it is done, what is remaining in B, which is going to be n minus 1 disk, move this n minus 1 disk from B to C by taking help of A. This is going to be a recursive function for us.